Hello and welcome to the new episode of Artillery OS. We will make very exciting addition today. Today we will create the terminal of our operating system. This terminal will be used when we want to print text on the screen and receive input from user. And it is indispensable feature for almost every general use operating system. So as you remember from last video, we managed to boot our kernel and now we can continue to develop our kernel in C. And today we will use VGA text mode to create our terminal, and we will able to print whatever we want directly accessing the video memory. Let me explain you what this text mode is. VGA text mode is a display mode used by older computer systems, particularly those that utilize VGA compatible graphic cards. VGA text mode is character-based display mode that allows text character to be displayed on a screen using grid of character cells and typically arranged in rows and columns. As we progress in our project, we will exit text mode and enter graphics mode, but for now we will use text mode. So let's get started. First thing first, I want to implement the constants and function declarations. So I'm going to create a header file and include tty.hash. So let me just handle the regular stuff down there. So let's start to define our constants. For the most of the systems, video memory address starts from 0xb8000. So we are going to talk this guy today. And the regular height of VGA is 20 pixels. And the regular height is, regular width is 80 pixels. And our goal today is printing this on screen today, okay? So let's get started with initializing our terminal. Let's create a source file. And before forgetting it, let me add this on our make file. So just copy and paste it. Okay, so let's include let's create our video buffer from our constant. Let me just copy it. Okay, and let's implement our first terminal. So it's actually pretty easy to communicate with a video buffer. So all you have to do is pass a character to it. Let's say A, okay? And this is not I, this will be a 0. And the second character defines the color of it. So VJ has 16 colors, I guess. Let's just use magic number for now, but we will create an enum for this later. So hopefully this will print A in red in screen. Let's test it on our main function. So I'm going to include tty.hash and terminal int right there. Okay, let's build it. So we got a typo down there. let me fix. Okay, build it and let's test with camel. As you can see in the screen, we got a red A here, and this is how we can talk in video buffer in VGA text mode. So as you see, this is not a very useful usage of video buffer. So let's create a new method. So I'm gonna need st include std int, I guess, for this, and this is gonna be 16 bits. Terminal make char, and this will get character and int. Okay, this is for our character and this is for our color integer. Okay, so let's continue with implementing our terminal make char, and I will show you a little very basic bitwise trick. So as you know, video buffer takes 16 bits as an input. So and we need to implement a make char function because this usage is far from optimal. So let's implement this, and let's change the type of our video buffer. So if we shift left the character by 8 bits and or with our color, actually this is what we get. Let's say our character is 0x41 and our color code is 0x02. Okay, if we shift it, this is what we get. And this is what shifted value looks like, and if we OR it with color, this is what we get. And if we pass this on our video buffer, we can able to create a character actually. Let's try it. Okay, so I'm gonna delete this and pass it directly there. Let's make a B in color 2. Okay, so let's build and run it. Okay, we have a little problem because we have to shift the color and sum it with character, because this issue is occurred because endianness. So okay, let's build it again and run it. As you can see, we can see a green B in the screen. So this is works, and after that we need to implement our other helper functions for better usage. Okay, so let's define them first. What we need is we're gonna need a terminal put char, and this is gonna be a void, I guess, and it gets x and y coordinates. Okay, and what else? It's get a character and color code, and we need a terminal write function, and it's gonna write into our buffer, video buffer, and again it gets character and color code, and after that we need to print in a color mode. We're gonna pass it a string with color code. Okay, these are what we are going to implement. So let's get started and create our first terminal. So input char, we need rows and columns. So int let me just check it. Let's make it 16 bits too. Okay, not integer, because it will be a 16-bit and unsigned. It can't be a negative. So let me name it terminal row, and it's gonna start at 0.0. And we're gonna need terminal column. Okay. So if you want to implement a put char, we're gonna need video memory, video buffer, sorry, and our x, and our y. This should be multiplied with our VGA height because of the array and memory operations, and we're gonna sum it with our x. And then we're gonna pass our makeChar function to actually create something on screen. And it's gonna be, so I need to define this. So okay, so this is basically prints character on screen with given x and y coordinates. So let's apply it in our terminal, right? So there's something specific in there. If you see \n, we have to manage this like a typewriter, you know. If we see this special character, we have to increment our row, column 0 and row 1. So eventually, if we see this, our column value will be 0, and we are going to just going first part of the screen, and our row will be increment. That means we are going through the next character. Let's firstly implement this. Okay, so we have a character, and we have a color of this character. So if our character equals to \n, we are going to okay, we are going to set our terminal column to 0, and we are going to increment our terminal row, right? So this will give us our typewriter effect, hopefully. So let's continue. We are going to put terminal char, and we are going to use this. And our x coordinate is terminal row, sorry, terminal column, because column refers to x and row refers to I. So let's write them. Let me just copy and paste it quickly. Our character is our eventual character, and we are going to pass our color. So if our terminal column just copy and paste it, is higher than our VGA width, we are going to set again this structure. Okay, terminal column will be 0 and terminal row will be incremented for going through the next line. So eventually we have to print a string with these helper functions, but before diving into string, we have to implement size. We need, because we have to know the size of our string, right? So let's implement this. I'm gonna make it size t string len, and it's gonna take a character array. So while string len is not null, we are going to increment len, and when it is going to end of the string, it will quit the while loop, and we just return it. It's just basic string length function. Okay, so we can able to write our first print function. So let's get started. Okay, so we are going to take the size of our string, and we are going to write them in our terminal. Like, this is just that easy. It's hilariously easy. Okay, we are going to write them. So our character is our stri, and our color is color that passed by user. So in theoretically, we are able to print our initial message. Let's try. But first of all, I want to clear the buffer first. So we need to have two for loops for that. So the first for loop is going to be let's make it y. Okay, let's go with the height, and this is gonna be smaller than PGA height, and x gonna be start from VGA width. Okay, so let's print black on the old screen for cleaning them. So I'm just gonna terminal put char, and it's gonna be x and y, and my character is just blank, and I want black. So after that, we are able to print our initial message. So we are going to use terminal print color. Let me check our message first. It's terminal message, and I want to make it red. Okay, so let's try this. Let's try and see if we are actually able to print something on screen for the first time. Okay, we got a bunch of errors because I forget to include std_defs here. So for using size D, I guess. So actually we have to define the string length here too. Okay, it's compiled. Let's try it. Okay, we got a real problem down there. Let me check it.
A few moments later.
Oh, okay, I found the issue. This is gonna be X. So, okay, we have a little bit issue again. So when we putting this, we have to increment this too. Okay. Let me just fix quick. Okay, this should be work. Okay, as you can see, we are able to print our first message and initialize our first kernel. So thank you for your time. See you next video. Maybe next time we will implement our GDT. So thank you for watching. Have a good day.